Hi there everyone, this video today we're going to be talking about area. Now a lot of this stuff I think you would have seen before. If you have a look at these formulas on this page, you've probably seen these formulas for years and years. Area of a rectangle, circle, triangle, parallelogram. Trapezium's a little bit tricky. Half times a plus b times h. And a rhombus and a kite are both the same formulas. Half the product of the diagonals gives us the area there. So those formulas are your basic area formulas. I'm just going to do a few examples here using those formulas. Okay, first one here, we've got a parallelogram. Notice that the area of this thing here is not just the base times this length here. This is just basically a rectangle that's been tilted over. So we know the formula for a rectangle is base times height. So when we tilt this thing over, it's still the height that we're looking at. So the 80 centimeters comes into play. So the area of this thing here is just, well, I guess you could tell me what's wrong if I just write that. Okay, we've got mixed units, and that's a tricky thing here. We want the answer in meters squared, so I'm going to write everything in meters. So 80 centimeters in meters is going to be 0.8. Okay, 0.8 of a meter. So now we've got it in meters squared. 1.4 times 0.8, and I'm going to cheat here, is 1.12 meters squared exactly. Triangle over here on the right, the area is a half times the base times the height. Okay. Simple formula for the area of a triangle, and again I'm going to be cheating. A half times the base times the height. That is 147 centimeters squared. Easy. Okay, these two examples here are what's called compound shapes. So just a little bit trickier here to find the areas. I think it's really obvious for the first one that what we were going to do is we're going to find the area of the whole rectangle here and then subtract off the area of this circle in here. That's obviously the easiest way to do this one here. So I would say that the area is, and this is all going to be in millimeters squared, so 18 times 11, that gives us the area of the rectangle, minus the area of the circle, which is pi r squared. And given that the diameter there is 5 millimeters, there we go, something like that. And you can do that all in one step on your calculator. You could do it separate, but I just do all that on my calculator, and that gives us about 178 millimeters squared. In part B, you could also do the same thing. You could draw a line across the top here and say that the area for part B is the area of the rectangle, which is just 12 times 10. So that's just this whole rectangle here, minus off the area of that triangle there at the top. Okay, so the area of a triangle is a half times the base. The base is 10 times the height. Now the height of this triangle is this length right here. And hopefully you can see that if this length is 12 and this length is 8, that length there must be 4 centimeters. So there we go there. 120. You could almost do this in your head. This is 40 divided by 2, so 20. So this is 100 centimeters squared. And don't forget the units on the end there. Okay, last one in this video, we want to find the area of this figure. It's a trapezium. So we could use the trapezium formula, or you might look at that and think, really, that is a rectangle with a triangle on the end of it. And that's cool as well. You could certainly do it that way. So one measurement that we're missing here that's really vital is this length right here. Okay, the height of the triangle, or the height of the rectangle there. If you look at this right angle triangle ECD, you can see right angle triangle. To find that height, we could use Pythagoras. So if I give that an x, we could say x squared plus 5 squared is equal to 13 squared. And a bit of Pythagoras here. X would be 144. X squared is 144. X is actually 12 meters. Okay, so Pythagoras there tells us the height there, and that's really all we need to find this one out. So let me do it using the rectangle and adding on a triangle. So the area would be 11 times 12. That's this area here, 11 times 12, plus a half times the base, which is 5, times the height, which is 12. Great. 132 plus a half of 60, which is 30. So we get 162 meters squared is the area of that figure. You could also see this shape as a trapezium. So I'm going to do the same thing, but I'm just going to use the formula for the area of a trapezium. So you've got a half a plus b times h. So in this case here, the a and b are just the lengths of the parallel sides. So it's 11 is one length here, and the other length along the bottom here, AD, is just 11 plus 5, 16. So 11 plus 16, and the height is just the distance between the two parallel sides. So in this case, the height is 12. So if you put that all in your calculator, you'll get 162 meters squared also. So same answer.